Okay, 7.1, graphing exponential growth functions, okay? 7.1 is just talking about growth functions, okay? Not decay, growth, okay? Our standard or our parent function is f of x equals b to the x power, okay? It's exponential growth, makes sense. It has an exponent and it's growing, okay? Where b has to be greater than 1. So this point here, 1b, is greater than 1, okay? It's exponential growth. Now, when we graph, let's remind ourselves and talk about some of the rules when we graph. How do we know if something stretches or shrinks?
The whole number and a fraction.
Yes, a whole number or fraction in the beginning. I'm multiplying by a whole number or fraction. Good, Cole. How do I know if something flips?
If it's a negative.
If it's a negative. How do I know if my vertex or my original starting point shifts left or right?
If it's minus, or is it plus or minus?
Plus or minus to what? What does it have to be added or subtracted to? Your vertex is represented by what two letters usually?
H.
H and K, right? So if I have HK, if something is added to my H, right, it shifts it left or right. If something is added or subtracted to my K, it shifts it which way? Up and down, okay? So here, we have a standard function. There's nothing really happening too much to it, right? Because I have b to the x, I have 2 to the x, right? So I have y equals 2 to the x. It wants me to graph this. How do you think I go about graphing that?
Plugging numbers?
Just plug in numbers, yes, plug in numbers. Okay, so can I have negative exponents?
Yes.
Yes, I can. So I'm gonna plug in some negatives, a 0 and some positives, right? If I were you to this graph, I would just plug in -2, -1, 0, 1, and 2. Make it easy, yeah? Because it's a standard easy function. What is 2 to the -2? Remember when we have exponents?
Oh,
Ooh, remember exponential
one.
rules. If I have 2 to the -2, what does it do to this exponent? What's it do?
It makes it a fraction.
Makes it a fraction, makes it 1 over 2 squared. What's 1 over 2 squared?
Oh, 4.
1/4. Don't forget, when you have negative exponents, you have to flip it, because Drew was technically right when he said, no, we can't have negative exponents. But we can, we just have to flip it and put it in fraction form. Remember? Okay, what happens when I have a -1 to the -1? What happens there?
1 over 2.
Yep, so it just becomes 1
1
half.
half.
What happens when I have 0 in the exponent spot? 2 to the 0?
It stays as 2. Oh, no, it's 1.
It's 1. Anything
One.
to the 0
One.
power is 1. Woo, we're gonna remember, I can tell. Okay, what's 2 to the first?
That's 2.
2. And what is 2 squared?
4.
4. Beautiful.
Just like.
So I graph this. -2, 1/4, right?
Yeah.
And then I graph -1, 1/2. And then I graph 0, 1. And then I graph 1, 2. And then I graph 2, 4, yeah? And look. Okay. Boom. I have graphed that one. Can you handle doing that simple one?
Yes.
Yes. Okay? That's not hard. That's not bad, right?
Doesn't seem hard.
Doesn't seem hard.
Fraction.
Now, when I graph y equals 1/2 times 4 to the x, what do you already notice about this graph? What's going to happen to it?
It's going to shrink.
It's going to shrink because it's got that 1/2 in front. Okay? But we're still going to plug in numbers just like we did over here. We're going to say x, y. We're going to plug in -2, -1, 0, 1, and 2 again. Okay? Keep it simple. When I plug in -2 this time though, right? I have y equals 1/2 times 4 to the -2, yeah? Okay, what do I have to do here first?
Flip it.
Flip it, so I get y equals 1/2 times 1/4 squared, right? What's 1/4 squared?
1/16.
So then I get y equals 1/2 times 1/16, which gives me what? What's 1/2 times 1/16?
Is it 180?
No, what's 2 times 16?
Oh,
32, so it's 1/32, yeah, 1/32.
Yeah, I think
Okay, 1/32. Now, that's shrinking it. Do you notice that? Look at the difference here. When I plugged in a -2 here with the half in front, I get 1/32. When I plugged -2 in here, I had 1/4. You see the difference? Shrinking, okay? Pretty drastically too. For, the second part is 4 to the -1st. What do I have to do?
flip it,
Flip it so I get 1/4 basically, right?
yes,
Okay, what is 1/2 times 1/4?
20.
20, beautiful. Y equals 1/2 times 4 to the 0. What's 4 to the 0? 1, so I get y equals 1/2 times 1, which means I get y equals 1/2, beautiful.
Oh, so when it's 0, will you automatically get, that number?
Yes.
Alright, so I have a problem.
Okay, what's your question?
Not a problem, question.
Okay, what do you
So
got?
are we always gonna plug in -2?
I would say most of the time, yeah, just plug in -2, -1, 0, 1, and 2. Every once in a while, remember when we look at stuff, we're like, well, those numbers won't be good. Like when we get over here, we'll talk about some stuff that would make it easier, because there's a -1 up there with that x, yeah? Okay, but here, yeah, pretty simple. Okay, if I plug in a 1, that means I have y equals 1/2 times 4 to the 1st. What's 4 to the 1st?
4,
So I have 1/2 times 4. What's 1/2 times 4?
2,
2. Now, y equals 1/2 times 4 squared, right?
yes,
What's 4 squared?
16,
And what is 1/2 times 16?
8.
8. Okay, so I have 2 and I have 8. 2, 4, 6, 8. Beautiful. I have 1 and I have 2, right? 1, 2. And I have 0 and I have a half. And I have -1 and 1/8. And then I have -2 and 1/32. So this graph goes something like this. And remember, yours always looks nicer because it's on graph paper. So there's my graph. You see the difference between the parent function and all of these? Okay. They're a little bit different.
So does it have to be perfect, or can it be like, as long as it's in the right direction?
As long as you have your outputs for me.
Okay.
Remember how we did that last year? Have your outputs and then you can estimate where the graph goes. I know it's not gonna be exact. Okay? Now, what do we notice about this graph here? Y equals -5 seconds to the x power.
It's gonna reflect.
So it's going to reflect. So it's going to go like this. Okay? Instead of coming up like this, it's going. Okay? Now that's not a decay growth. This is still a growth model. It's just that it flips over the x-axis. Okay? It's just going to look a little different. Once again, just choose the same numbers. Very simple. Okay? Make life easy for yourself. -2, -1, 0, 1, 2. Now, if I plug in -2 in, that means I have y equals -5 seconds to the -2. What happens here? When that happens, what do I do? What happens with these?
Don't they both get the?
They both get the 2, but what else has to happen to them?
They have to flip.
They have to flip, so I get 2 squared over 5 squared, okay? 2 squared over 5 squared. What is 2 squared? 4. What is 5 squared?
25.
25. So I get -4/25, right? Because I have that negative out in front still. -4/25, okay? -4/25. Because that can't reduce or anything, right? No, okay. Y equals negative, and then I have 5 seconds to the -1st. What do I do there?
Flip,
Flip, so you just have 2 over 5, right?
yes.
And so that means it equals, y equals -2/5, right? Okay, beautiful. And what happens when I have y equals -5 seconds to the 0 power?
1,
So I get y equals -1,
yes.
okay, because that negative is still up in front. And then y equals negative 5 over 2 to the positive 1, right? So then I just get what?
Negative 5.
Negative 5 over 2. What is negative 5 over 2 decimal wise? Do you know? 2.5,
5.
yeah. I'm just gonna kind of put that up here so that I can remember if I want to. Because I don't care which way you write it, but usually you guys give me the decimal if I remember correctly. So negative 2.5, okay? And then, let's see here, we got 2 left, right? So I have negative and I have 5 over 2 squared. What is 5 squared? 25, right? And what is 2 squared? 4. How many times does 4 go into 25?
6 times.
6 times.
Oh, yeah, 6 times.
Yeah, 6 times with the remainder of 1/4, right? Yeah. So I technically have negative 6.25, right? If you want to write it that way, okay? Which might be easier for graphing in our minds. So negative 2, negative 4 25ths. Negative 2, negative 4 25ths. Let's say that's right about here. And negative 1, negative 2 fifths. And 0, negative 1. And 1, negative 2 and a half. And 2, negative 6.25. 2, 4, 6 and a quarter. Do you see how this graph is going? Okay. So it's still exponentially growing, it just got flipped over that x-axis. Cool? And then we're gonna do one more, and what do you think your homework's gonna be all over?
This.
Just graphing. And this is only part of the lesson, we're gonna talk about other parts of it tomorrow. We still have like 2 or 3 more examples tomorrow, okay? So, let's look at this. First of all, it wants us to graph 4 times 2 to the x minus 1 minus 3, and then it wants us to state the domain and range. What's domain and range?
X and Y.
X and y, what does that mean?
The input, whatever.
Yeah, and domain means how far it goes on the x-axis, and range means how far it goes on the y-axis, okay?
So does just one like the first point and the last point, or?
No, remember last year, Drew, we would say like y is greater than
Oh, yeah.
3 or whatever, okay, and we would do it that way. So we're gonna talk about that. But before we talk about that, okay, we are going to graph this in a way that's different than what you think, okay? We're gonna forget about this -1 and this -3 for a second. And we're going to graph by inputting numbers into 4 times 2 to the x power. And then once we graph that, we're going to shift it with that -1 and -3. Because if we try to plug numbers into this whole thing, we're going to mess stuff up eventually. So we're going to focus always just on this first portion before anything shifts. Okay? So I'm gonna take the portion y equals 4 times 2 to the x. And I am going to make a chart again and plug stuff in. Once again, I'm going to choose the numbers -2, -1, 0, 1, and 2. Okay, make it easy. And 2. Okay, now let's start there. Y equals 4 times 2 to the -2. What do I have to do with that?
Flip it.
Flip it. So you get 4 times 1 over 2 squared. What's 1 over 2 squared?
1/4.
So you get 4 times 1/4, which gives you what?
1.
1. Beautiful. Then I have y equals 4 times 2 to the -1. What do I have to do? So I get 4 times 1 over 2, right?
Yes.
What is 4 times 1/2?
2.
2. Yes, 2. I don't need another step. 2. Beautiful. Now, y equals 4 times 2 to the 0. What's 2 to the 0?
1.
So I have 4 times 1, which is
4.
4. Then I have y equals 4 times 2 to the first. What's 2 to the first?
2.
So what's 4 times 2?
8.
Beautiful. Then I have y equals 4 times 2 squared. What's 2 squared?
4.
and what's 4 times 4? Okay, I'm going to count by 2's over here, okay? So this is 2, this is 2, negative 2, negative 2. So I'm gonna graph this, negative 2, 1, right? And then I graph negative 1, 2. And then I graph 0, 4. And then I graph 1, 8, 2, 4, 6, 8. And then I graph 2, 16, 2, 4, 6, 8, 10, 12, 14, 16. Now, this is not my graph overall, okay? This is just what I did when I graphed this portion of it. Now, what does that negative 1 and that negative 3 tell me?
It's gonna shift
Shift what ways?
left or right.
Okay. What does the negative 1 tell me, up or down?
Down.
Down, so I'm shifting down. And what does the negative 3 tell me, left or right?
Right.
Ooh, right, remember that one's always opposite. So I have to shift, okay? I still have to shift up 1, right 3, okay? So for everything, every point that I have here, all of these points, I have to add a 1 to this part, right? And I have to add a 3 to this part. Does that make sense, what I'm telling you? Okay, so these points are going to shift over. It's much easier to do it this way and shift them than to try to do it all from the beginning, because you're gonna mess it up. Yes?
Now, do we have to label the points, or can we just have the chart and then?
You can just have the chart and add and subtract, yeah, that's fine. So, this new point becomes what?
Negative 1.
Yes, negative 1, 4, okay? So I'm gonna come over here and I'm gonna go negative 1, 2, 4, right? Negative 1, 4, okay? And I do it that way. Wait a second. Why did I write up? This should be down. You told me down. I'm being silly. So this is all down. I'm sorry.
Is it left 3?
Yes, no, it's right 3.
That's right, because.
The y is always opposite of what it shows, the x always stays true to it. Okay, sorry. So not negative 1, it should be negative 3, right? Okay, so negative, am I right on this? I'm being crazy right now, I'm sorry. Give me 1 second to get my bearings. 0, 4 would go to negative would go to 1, negative 1, 3, right? Or would it go to 1, 3? Okay. So you sketch the graph, then you translate the graph, right 1 unit, down 3 units. Right 1 unit, down 3 units. Right 1 unit, down 3 units. Yes. Okay. X tells us left and right, right? So right 1 unit, down 3 units, because the y is what's telling us this. So right 1 unit, down 3 units.
Is it, wait, so it is right 1?
Okay, yes, because x tells us right and left, y tells us up and down. So right 1, down 3, right 1, down 3. Okay, so this becomes negative 1, negative 2, yeah? So negative 1 and negative 2, we're counting by 2's. And then this point becomes 0, negative 1, right? 0, negative 1. So 0, negative 1. And then this point becomes 1, 1, 1. 1, 1. 1, 1, 1, 1. And then this point becomes 2, 5, yeah? 2, 4, 5. And then this point becomes 3, 16, 15, 14, 13. 3, 13, yes? 3, 2, 4, 6, 8, 10, 12, 13. And I have shifted my graph. Now, listen to this. This is where my domain and range come in. My domain and range come from here. Remember that? So my domain is what? What is my domain in this case? How far, okay, look at this graph. How far does this graph continue left and right? Look at my arrows. What does that tell me? That they're always what? Continuing, right? So if they're always continuing, is my domain stopping ever?
Oh, no.
No, so my domain is what? What's that term we use for it?
All these numbers?
All real numbers. So on these graphs, let me tell you a little hint here. On the graphs that deal with exponential growth, it should always be all real numbers for domain. Okay? Very seldom is there a case where it's not going to be that. Okay? All real numbers. Though the case it will be like that is like this. If you have a company, okay, can you have a negative amount of money that you're making? No, because then what happens? You're out of business. So that would be like a case where the domain cuts off at 0. Does that make sense? You can't have less than $0 for a company to continue, okay? So if you're doing live applications and stuff like that, but otherwise, domain for exponential growth continues on forever, okay? What is my range? What is my range? What is my range? Yes, y has to be what?
Less.
Greater than or less than? Is my graph going up or down?
Yeah.
My graph's
I mean, it's going up.
it's going up, so y has to be greater than -3. Okay, that's how I'm doing domain and range on this.
Now, will there be cases where both of them are gonna be all real numbers?
Oh, that's a good question, but no, because that would not be an exponential growth or decay problem then. It would be, remember the ones we did last year that were like this? Like that, like they came like this, right? And they continued this way and this way forever? Yeah, that would be a different type of growth. It's not.
So the range would always be the